In this video, I will outline the methods of depositing a film on a bottom-gated, bottom-contacted OFET substrate in order to subsequently test it. The contacting and testing of the substrate will be covered in a subsequent video. Here I'll be using a substrate manufactured in a previous video. Further, in techniques shown in another video, it has been functionalized with OTS. There are quite a few methods of deposition, including vacuum deposition, spin coating, drop casting, inkjet printing, and sputtering. Here I will focus on drop casting, spin coating, and blade deposition. The first step to these methods is to dissolve the compound into a suitable solvent. The compound should be mixed with solvent until it turns transparent, indicating dissolution. Sometimes this will take some time and require stirring or ultrasonification. Additionally, heating may be used to help the compound into solution. Caution should be maintained with heating, however, as a supersaturated solution can form, which when cooled down again can rapidly form aggregates, making a suspension, or entirely precipitate a compound. With polymers, this is more complicated, as gels may form prior to precipitation. P3HT is shown here, which it is claimed can form beneficial aggregates. The paper is linked below. Regardless, precipitation, aggregation, and gels can affect the films formed, and so caution should be maintained about cloudy solutions. Once we have a compound in solution, we can start depositing the films. First, I will show drop cast film coating. In order to do this, a small amount of compound is dropped onto the gate section of each substrate. The compound may be optionally heated during this step. Subsequent to it, the substrate is often annealed. In this example, I have used 1 microliters of 0.5 mg per ml P3HT in a 1:4 mix of chloroform and orthodichlorobenzene, heated to 50 degrees Celsius. The resulting film, as imaged under a microscope, is shown here. A major disadvantage of drop casting is that it often produces quite inhomogeneous films. This inhomogeneity can produce numerous issues such as non-uniform charge flow and trap sites. A second approach is spin coating. Spin coating involves depositing compound in solution onto a spinning substrate. This tends to produce more uniform films. In order to do this, commonly a quantity of solution is deposited onto a substrate and then it is spun at a prescribed speed. Here I am using 100 microliters of 5 mg per ml P3HT in a 1:4 mix of chloroform and orthodichlorobenzene. It is also possible to deposit the compound while the substrate is spinning. However, how well this method works will depend on the substrate. The final method I will be showing is blade deposition. This involves scraping a blade along a surface coated with a solution of the desired material. There appears to be two ways of doing this method. Either the compound is directly applied to the surface and then the drops are spread by the blade, or the compound is applied to the blade and the surface tension is used to drag the solution along. The most common method by far appears to be applying drops to the surface and dragging it along. However, here I do it via applying the drops to the blade. I'm using 10 mg per ml of P3HT in toluene and adding 15 microliters. Currently there appears to be some problems with this method. It is suspected it is related to the surface tension of toluene, causing banding in the deposition. I am still troubleshooting this. After depositing, it is necessary to remove the excess material which covers the contact pads. That is, the parts of the substrate we wish to attach our electrodes to. In order to do this, it is necessary to wet a cotton bud with a suitable solvent and wipe the compound off. A suitable solvent would be one which readily dissolves the compound. The final OFET is thus made. It may now be used and tested. The testing and contacting of the substrate will be covered in another video.